Okay, so let's take a look at pages 190 through 192. Yeah. So the first problem here says, given the figure above, prove that it is specifically a rectangle and not a square. And there are several ways to do this, and we're going to do a few of them. Now let me just first start out by saying, if I asked you to prove that this was specifically a rectangle and not a square, you pick one way that you want to do it. You do not have to do it multiple ways. This is just to show you the different ways you could choose, and really to give us practice in writing these proofs. So you should not be thinking that you have to do this the same way I do. Okay, so again, this is the first one. We've practiced the midpoint formula, the distance formula, the slope formula, but this is really the first time that you're going to see a diagram here, so that you'll see what we're talking about. So the first thing I would suggest doing is going through and labeling all the points. Right, so this is the point -5, -1. This is the point -4, 3. This is the point 1, 2, 3, 4, 5, 6, 7, 8, 0. This is the point 7, -4. And this right here looks to be about 1.5, -1/2. So I'm going to say 3/2, -1/2. Right. And it's asking us to prove that it is a rectangle and not a square. So it says, first show it's a parallelogram with one right angle and sides and two sides that are not congruent. Right. So prove it's a parallelogram. In other words, show that the opposite sides are parallel, that has one right angle and two sides that are not congruent. In other words, it's not saying these two are not congruent or these two are not congruent. It's saying these two are not congruent. Okay, so adjacent sides are not congruent. Okay, so again, I'm looking at my sheet. This was the page 188, and in order to show that it's a parallelogram, I'm going to choose the first option there, which says show that both pairs of opposite sides are parallel. I just prefer the slope formula over the distance formula. So that's what I'm going to do. All right, so I'm going to show it's a parallelogram by showing that both pairs of opposite sides are parallel. Okay, that's the route I'm going. All right, so that means that we have to show that AD is parallel to BC. Oops. So show this, and AB is parallel to CD. Right, so that's what we have to show for the parallelogram part. So let's do that. And again, this requires the use of the slope formula. So I'm going to come here and I'm going to say the slope of AD is going to be found by doing the y coordinates, so 7 minus -1 over -4 minus -5. So that gives me 8 over 1. So the slope of AD is 8. Let me just check. That seems really too high. -4. Oh, I know why. Because I used the wrong values. I chose the X one right here. Let's fix that. This is not the y coordinate. It's -4 minus -1. And then it should be 7 minus -5. That makes a lot more sense here. Sorry about that. So -4 minus -1. That gives us -4 plus 1, which is -3. And then 7 minus -5. That also can't be right. My goodness, what am I doing here? -4 minus a -1. That becomes plus a positive. That's -3. And then 7 minus a -5. Oh yeah, duh, it is negative. That gives us a slope. That gives us 12. That gives us a -1 over 4 is the slope. It's late at night right now. It's after 9. It's past my bedtime. Okay, then let's do the same thing for BC. Slope of BC. All right, we're going to do, let's make sure I get them right, y, which is 0, minus y, which is 3, and then x, which is 8, minus x, which is negative 4. That gives us negative 3 over 12, which is negative 1/4. Okay, so we just proved this. And then here, to do AB is parallel to CD, we're going to do the slope of AB is equal to, all right, AB is this here, so we're going to take the y, which is 3, minus the y, which is negative 1, over the negative 4, which is the x, minus negative 5, which is the x. So here we get 4, and down here we get, that's plus a positive, so this is 1. So that's a slope of 4. All right, slope of CD. So we're going to go here. So we're going to do y, which is 0, minus y, which is negative 4, and then 8 minus 7. So 0 minus a negative 4 gives me 4, and 8 minus 7 is 1. So that's 4. All right, so show it's a parallelogram. Done. With one right angle, so that means that we need to take two adjacent sides. So let me pick A, D, and DC, and we need to show that they have a right angle there. And again, in order for that to have a right angle, those two sides have to be perpendicular. So let me just look at AD, that has a slope of negative 1/4, and CD has a slope of positive 4. Now, in the last video, I just said that in order for lines to be perpendicular, their slopes have to be opposite reciprocals. So you have to look at the signs, and one has to be positive and one has to be negative. That is the case here. And then reciprocals, in other words, to flip this fraction and get this. So if we flip 1/4, we do get 4, right? So we'll have to, when we write our summary, we'll have to say that in there. And then the third thing we have to do is we have to show that two sides are not congruent, right? So again, we would take two adjacent sides to show that they're not congruent. So we're going to have to find the length of AD and the length of CD, right? So here we're going to do the distance formula. So AD is going to be the distance between, so let's see, it is x2 minus x1 squared plus y2 minus y1 squared. 7 minus negative 5 is 12, and 12 squared is 144. Plus, no, I do want that there. Negative 4 minus a negative 1, that would be negative 3, and negative 3 squared is 9. All right, so I'm just going to keep carrying down the AD. All right, AD is 144 plus 9, which would be 153. That is nasty, but don't change it. Just simplify it. Actually, I don't even care if you simplify it, really. We just need to show that CD is not equal to square root of 153, right? And then that would show that they're different. From the diagram, it's clear that they're not the same length, but again, we always say don't rely on the picture, so we're going to prove that they're not equal by finding their length. So we just found out that this one is square root of 153. We just have to show that CD is not square root of 153. So for CD, we're going to write the square root of, right, so it's the difference of the x coordinates, so 8 minus 7 squared, plus the difference of the y coordinates, so that is 0 minus negative 4 squared. This is the square root of 1. Plus 0 minus negative 4 is 4 squared is 16, right, which tells us that CD is square root of 17. And these are clearly not the same. All right, So then what we have to do is we have to write a summary, right? And I am going to do that on the back of a different sheet of paper because again, writing under my tripod right here, I can't write as small as I normally would. So let me just summarize or write the summary of what we would do for this proof. All right, so I'm going to move this out of the way, and I'm just going to write it out. All right, so to prove that ABCD is a rectangle or a non-square rectangle, we showed that ABCD is a parallelogram by showing AB was parallel to CD and AD is parallel to BC. All right, this had slope m equals 4, and this was m equals -1/4. We then showed that angle D is a right angle because the slopes of AD and DC are perpendicular. -1/4 and 4 are opposite reciprocals. Finally, these two statements prove that ABCD is a rectangle. To show that ABCD is not a square, we showed that AD and DC are not equal to each other, and that was square root of 153 is not equal to square root of 17. Therefore, ABCD is a non-square rectangle. Okay, so again, essentially what we just did was on this page, and again, in the answer key, I put it all on one page because I could write really small. But on this page, what we did was we did all the computations that we needed to do. And on this page right here, I interpreted it. So I said what we did. To show that it's a non-square rectangle, first we showed it's a parallelogram by proving that both pairs of opposite sides are parallel. Then we showed that one of the angles was right, which gives us that these two adjacent sides are perpendicular because their slopes are opposite reciprocals. Therefore, it's a rectangle. But now for the final step, to show that it's a rectangle that's not a square, we had to show that those two sides were not equal, which we did. Therefore, it's a non-square rectangle. So this side just summarizes or states specifically why we did all the things that we did right here. All right, so that's the difference. One place you're going to show all your work, but then you must do an interpretation of it right here. And again, that's going to come in a sentence form instead of statement reason like we did typically before. All right, so that is the first part of problem 1. In the next video, I'm going to show you the second part of problem 1, which again is doing the same proof, but now we're doing it by different means.